Hello everyone, welcome to COMP125 Principles of Computing. In this video we are going to continue our discussion about the discovery of algorithms and in this set of slides we are going to talk about iterative control structures or loops. Okay, last week we have talked about the flow of the program. Actually, we have seen a couple of examples that we wrote by just writing some sequential set of statements. And then we have talked about the control flow, control structure that, this is going to be some property of the computers that they select and choose the next statement which should be executed. And we have talked about three different control structures. We have talked about the sequential control, which is going to be a set of statements that sequentially they will be executed. And we have talked about the conditional control structure that it actually allows us to choose between two options. If you combine them, we can be able to choose between more than two options. I'm going to talk about this one as well at the end of this lecture. And today the main focus of this this lecture is about the iterative structure. In the iterative structures we can design a set of statements, a block of statements that we execute them repeatedly until a specific condition actually met. So still actually a review from last week. In the conditional statements, conditional statements basically is just like what we do in in natural language, that we write a condition and the program will execute a block of statements just based on the result of the condition that will be evaluated. This condition will be a Boolean expression, so the result of that is going to be either true or false. So if it is true, the first block of a statement will be here block of statements A will be executed. If it is false, if that condition is false, this part will be executed. This is exactly the syntax in the pseudocode that we write, and here you can see the flowchart for that. The Boolean condition and expression that you check will be written in the diamond, and we usually just draw two arcs going out of this diamond, one of them marked as true. So if the Boolean condition or expression is true, the computer will go and execute this set of statements. For example, this block of statements, this one, and then at the end it actually reaches to here. If the Boolean Boolean condition is false, so it's just like the computer will be directed this way and it will execute all of these statements, and then it actually ends up here. So I think the flowchart is going to be really useful to give you this understanding that how the computer will deal with the for example a pseudocode that you write. If you write a pseudocode like this, what does this mean? The condition will be checked. If it is true, this part; if it is false, this part will be executed. So today we are going to focus on iterative control structure. Not only the if condition is required to write sophisticated problems, but also we need to repeat some statements. So using the combination of all of these three control structures, sequential, conditional, and iterative, we can write down very complicated problems that in the next set of slides and lecture we will see some examples of very complicated problems. So what is this iterative? How can we actually write some iterative control structures, This slide is actually presenting that what would happen here when you are writing a control, an iterative control structure, an iterative statement. In fact, you again are going to have a condition. That condition is a Boolean condition. So far, everything is similar to the if statement. You have a Boolean condition that you have to check. And if it is true, the difference here is that if it is true, a set of statements will be executed, right? Okay. And if it is true, not only this set of a statement will be executed, but also at the end, the computer will go back and check the condition again. Instead of just a stop at the end of the set of statements, the computer will go back and check the condition again. Okay, so that's why it will create a loop. It will iterate over this set of a statement. It's not just, and a conditional statement. It is an iterative statement that will execute a set of statements, a block of a statement, until the condition is true, for example. Okay, whenever the condition became false, it just exit the loop or just follow this path and goes and execute the set of statements that you have written after this block. Okay, so this is the main difference between a conditional statement and an iterative version. Again, in an iterative version, you need a condition, you need a Boolean condition, but the computer knows that at the end of executing that block, it will immediately go back and double check the condition again. If it is still true, this set of blocks will be executed again. So the set of statements, which we usually actually call it the body of the loop, will be executed again and again and again until the condition became false. So the only way that you can get out of this loop is that the condition became false. And this is something important that I will come back to it later. So there are two different ways that we can write iterative operations. One of them is called pretest, the other one is called posttest. What is pretest means? Pretest means that you check the condition before. So before doing the body of the loop, you will check the condition. Let me show you some example here. And I mean the syntax of the pseudocode, a flowchart, and some example. So this is the syntax of a while, because this is going to be in the iterative operations, we will execute a block of statements until or while a condition is still true. The command that we use in the pseudocode, and usually actually in programming languages, is the command we call it actually while. So in our pseudocodes, we will use this keyword while. And you say that, okay, while this condition is true, this set of statements, which we usually call it the body of the loop, this set of a statement will be executed. And we usually actually just mark the end of the loop as well and say that, okay, this is the end of the loop. After all of these statements have been executed, again, we will go back and check the condition. If it is still true, we will execute the line. And whenever the condition is false, you actually just jump out and you execute whatever comes after the end of the loop. Okay, so let me show you an example. Here is an example that you can see. I have written, for example, a variable counter has been set to 0 while counter is less than 100. This is the Boolean condition that I'm checking. Okay, and then while counter is less than 100, so because you have initialized it as 0, the first time that you are checking it, counter will be less than 100, right? This is true. So it is true, this set of a statement that it can be anything will be executed. And you can see that at the end, for example, I'm changing the value of counter. Counter will be increased by 1, right? So the value of counter will be 1, but this is going to be, one of the statements. and then you go back to the top and again check the condition. The condition is still true because counter is 1, it is less than 100, so the statement will be executed. The body of the loop will be executed again. Okay, I will show you plenty of examples, but let me actually just finish showing the explaining the syntax, then we will jump to the examples. Okay, so the flowchart of the pretest is something like this. You can see that diamond that checks the Boolean condition, the Boolean state, the Boolean expression will be checked first. That's why we call it actually the pretest. Okay, then if it is true, you will execute a block of statements here. And whenever you are done with executing all of these block of statements, you will go back and double check the condition. So if it is still true, you will go and execute the set of statements here again. So you will loop through all, you will iterate through all the loop, and whenever the condition is false, you will exit. Okay, so you can see that I'm doing the checking the condition before, at the beginning. So this is called pretest. So interesting, in computer, we can actually just, reverse this. By reversing putting the block of a statement on top in the flowchart and then checking the condition, the main difference here is that you can see that it's just like the computer will see the block of a statement first. It will execute this block of a statement. Okay, once it will execute the block of a statement, then it will actually reach to the condition, check the condition. If the condition is true, it will actually go to the beginning of the block and again execute that block of statements, then come back, check the condition, and so it is a loop. Okay, it is still a loop, but the main difference is that instead of checking the condition at the beginning of the block, I'm checking the condition at the end of the block. So the thing is, even if the condition is false, the block of statements will be executed at least once, right? So think about it. Computer will see the block of a statement, so the computer needs to execute this block to reach to the condition. Then it will check the condition. So even if the condition is false, the block will be executed once, right? And then, so the condition is false and it leaves. But in the previous example, in the pretest, you can see that if the condition is false, you don't execute the block of a statement at all. You just actually ignore it and exit the loop. So this is the main difference between pretest and this one, which is called, we call it post-test. When you are writing the pseudocode for that, we usually actually write it as a do while. So you can see that instead of putting the while here at the beginning, it's just like I put that set of a statement, and then I just put the while statement at the end of that set of statements. So you will execute the statements, then check the condition. Anyway, you will keep checking the condition to be able to stay in the loop and iterate. But the thing is, the main difference is that in the post-test, you will execute the loop at least once, even if the condition is false. And the do while loop, you in some actually cases, in some textbook, you might actually see it as a do until as well. So it doesn't really matter. It's just, the syntax that you use for your pseudocode. Okay, so we have seen, this is just the picture from your textbook. It shows you the post test loops or do while loop. You can see that I have a set of statements, the body of the loop or loop body, and then you actually put the condition at the end. So you execute the statements, check the condition at the end. If it is true still, you will actually go back on top and execute the set of a statement again. And whenever the condition is false, you just leave. Okay, this is the first example that I have written for you. This is a very simple example. Just assume that I am going to print 10 while the 10 whole numbers. So the whole numbers are going to be all integer numbers greater than 0. So this is going to be a number 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And 10, including 10. So 10 numbers. So how can I write a program for this one? The first thing that it might actually come to mind for you is that, okay, I can write down 10 print statements, right? So for example, I can write down something like this: print 1, print 2. Be careful, you cannot write, okay, print 1, 2, 3 until 10, because if you write such a thing, something like this, print 1 to 10, this one is not a primitive instruction. Okay, you cannot tell a computer just as, okay, print 1 to 10. Computer doesn't understand that what do you mean by print 1 to 10. Okay, so you have to just at each time tell the computer to print a single value. Okay, print 1, then print 2, then print 3. Okay, so after this step, one thing that you might come to mind for you is that, okay, just write down 10 prints. Print 1, print 2, print 3, and until print 10. You can see that this is really tedious work. You cannot really write down 10 statements. And what if I ask you to write a program to print the first 100 numbers, the first 1,000 numbers, the first 1 million numbers? This, you can actually see that this is not really practical, okay? So here is where I need to use the loop. The thing is, what you are doing in each of these lines is just printing a value, right? You are doing a fixed, actually a statement. So this is exactly where, a very suitable case that we can use a loop. I can say that, okay, the main thing that I have to do is just print something, but that something is going to be a value which is changing. First, I want it to be 1, then I want it to be 2, 3, 4, until it reaches to 10. Okay, so I can write down a while loop for that. Here I will define, because this value is changing, so the best thing that I can do is using a variable. I will define a variable, I'm calling it n, okay, and I initialized it as 1. Okay, because the 1 is the first number that I want it to be printed. And then I will use a loop. And first let's write the body of the loop. In the body of the loop, what I wanted to do is just printing that value n, right? This is the main thing. But not only printing n, I wanted n to be changing. At first it is 1, then I want it to be 2, then I want it to be 3. So you can see that at each step I am changing the value of n, and how I'm changing it, I'm just increasing it by 1, because what is the difference between 1 and 2? It is 1. Between the 2 and 3, it is 1. Between 3 and the next number, which is 4, it is 1. So what should I do here is that just updating n as well. So I will increase the value of n and say that, okay, set n to be n plus 1. So I increase it by 1. So this is going to be the whole body of the loop for me. But how many times, until when I should keep printing n? I'm actually interested in the first 10 whole numbers, right? I have started from 1. Okay, after n reached to 10, I want it to stop. So I can write down a condition and tell the while loop to just iterate until n is less than or equal to 10. So whenever n became greater than 10, it will stop. So when n reaches to 11, okay, this condition becomes false. Before that, this is going to be true. Okay, when is n is less than or equal to 10, whatever, this one is going to be true. Whenever it reaches to 11, it say that, okay, stop. I don't want you to actually iterate and print more because I'm just interested in the first 10 numbers. So here, actually, I have showed you the different parts of a loop. This part is called the body of the loop. This part is the condition, that Boolean expression that you write, and this part is the initialization. One thing that you have to be careful is that when you are writing the body of your loop, you should make sure that inside the body of the loop you have something to you have some statements that by executing these statements, at some point this condition became false. If this condition is never going to be false, you will actually get stuck in an infinite loop, right? Your program should be should terminate at some point. If your program doesn't terminate, if you have a loop that will iterate forever, you have an error in your program. So I'm going to show you an example of that later. So this was our first example. This flowchart is actually showing you that what would happen in this loop. You can see that this is the starting point of the flowchart. I have one statement here that set n to 1, and I have a condition. Again, I'm using a diamond here. I'm showing that, okay, I'm checking that if n is less than 10, if it is true, go here. For example, whatever I have written here, print n, right? Change n to n plus 1, increase n, and then this is the end of the loop, right? This is the end of the loop. So I will go back to the condition again check the value of 10. If n is less than or equal to 10, so come here again and repeat. If not, leave the loop, which actually goes to the end of the loop. So when you are designing your loop to solve your problem, you have actually three things to think about. The body of your loop, some initialization, because you are checking something, right? So that something needs to be written before that. For example, here the initialization for us was just initializing n to 1 because the condition have been written based on n. So we have three things: the initialization, condition that checks when the loop is going to end, and the body of the loop. Okay, so let me actually show you to you here that what would happen in this case. You can see that this is exactly similar to the previous pseudocode that I have shown you, but the main difference here is that I have removed that statement that was changing n to n plus 1. Remember that updating n, set n to n plus 1. I had this statement and I removed it here. What do you think would happen in this case? So the thing is, n was 1, right, at the beginning. N is going to be less than 10, so it is going to be true. Then you come here, print n, which is 1, so 1 will be printed. Then what would happen? So the computer will go back to the beginning of the loop and check the condition again. What is the value of n? The value of n is still 1. No one has changed n. So n is going to be less than 10 again. So it actually comes here in the body, execute the loop, print n, which is 1, and then go to the end of the while loop, and then go back and check the condition again. So you can see that because I'm not updating the value of n properly, not only I don't get those values that I wanted to print, but also it actually keeps going forever. So this pseudocode will keep printing 1 forever, and it will never stop, because this condition forever will be true, because n is always 1 and 1 is always less than or equal to 10. So it never became false, and your program is not going to stop. This is called an infinite loop, which is a very dangerous error, in fact, that you have to avoid it when you write your programs. Okay, let's see some more examples here. Here I wanted to, instead of write the first 10 numbers in increasing order, I'm interested in printing them in decreasing order. So this is actually showing you that what I'm interested in. I wanted you to write down some pseudocode that prints the 10 whole numbers in reverse order. First 10, then 9, then 8, then 7, then 6, and until you reach to 1. Okay, so again, you can see that here I am printing something, and this will be actually repeated for 10 times. But the values that I am printing, they are reversed. So what can I do? I need a loop. I can use a loop, but how should I actually write down my loop? So those values which I'm interested in, you can see that this time the first number that I'm interested in is going to be 10. Then it actually decreased to 9. Then it decreased to 8. So here you can see that I can find a pattern here again. I can say that, okay, I wanted some number that at first it is 10. Then it has been updated to 9. Then it has been updated to 8. What is the difference between all of these? They just decreased by 1, right? They will just decrease by 1, going down. So the loop that I'm going to write for this one is going to be something like this. Again, I will need a variable because this is something that will changing. I will initialize it with 10. Okay, this is the first number that I wanted it to be printed. Then in the body of the loop, okay, one thing that I want is just printing that value. And the other thing is that this value should be updated. So I will set n to n minus 1. You can see that I'm changing the value of n and I'm decreasing it. So it is first, then it will be 9, then it will be 8, and it goes down. So, and when should I stop? Whenever the value, the last item that I wanted to be a stop is 1. And after that, I want this one to be a stop. So what is the value that should be the threshold? So this is going to be the condition that I have to check here is that until or while n is greater than or equal to 1, go and execute all of these statements here. Okay, until n is greater or equal to 1. Or you can actually, instead of this one, this is completely correct to write as n is greater than 0. So you see that this Boolean expression and this one are completely the same. So if n is greater than 0, this is just like you write it as n is greater than or equal to 1. Both of them are going to be equivalent. Another example, this time we wanted to print even numbers less than 10. Okay, so I don't want all of the integer numbers between 1 and 10. I just want those which are even. So I want 2, 4, 6, and 8. This is something that I want. I don't want 1 or 3 or 5 or these odd numbers to be printed. So what can I do in this case? Again, you can see that here I am looking for some specific thing. I want it to be printed. And so this is just repeated again and again and again. How can I write a program for this? I can use a loop. So the first thing that comes to mind is that, okay, I will start from something. The first item that I'm looking for is 2, right? I should find a pattern between those values that I'm looking for. The values that I'm looking for is 2, and then it is 4, then it is 6, and then it is 8. So what is the pattern between these numbers? You can see that the change here is just you are adding the number by 2, and then you add it this number by 2. So this is the pattern that I'm looking for. Okay, and when I should stop? Whenever you reach to 8, or for example, you can say that whenever until it is actually less than 10. Okay, so this is going to be the condition. I found everything. This is the initialization, this is how I have to actually update, and this is the endpoint, which is going to be when you reach to 10. So this is going to be the full pseudocode. I have initialized n to 2. The main action that I wanted to do is just printing, but how I'm changing the value of n, that pattern was updating n by increasing it by 2, right? So these are the two main actions that I want to do. And then when I should stop, the condition is that until the value is less than 10. So it's not going to print 10. You can see that this condition is just checking that until it is less than 10. One more example here. We want to print the first 10 even numbers. Okay. Kind of, this is similar to the previous example. You would probably say that, okay, for this one, I can just use the previous example, but I need to figure out when to stop, right? The condition to stop should be changed. So I would calculate, say that, okay, the first even number is 2, the second one is 4, the third one is 6, and you count until you say that, okay, the 10th number is 20. Okay, so I can go back and just use this condition and change my condition to say that, okay, until it is less than 22. So this is going to work. But you can see that if I change this and say that, okay, print the first, I don't know, something like 47 even numbers. How are you going to do that? You have to actually just go and again calculate and see that what is going to be the 48 numbers, so put it as a condition, right? But I can do something easier, something that actually makes it simpler. One thing that I can do is that I can say, okay, I am interested in 10 numbers, okay? I am interested to print 10 values, right? But those values has a pattern to be actually created. Those values are going to be, for example, 2 and then 4, then 6 and so on. So there is a pattern here that the value that you are interested in will be started from 2 and will be actually increased by 2 each time. But how many of these values you need? You need 10 of them. So this one is corresponding to the first one, second one, third one, until, for example, the 10th number. So instead of just using one variable to create the number, I can still actually keep that variable for myself, that n initialized to 2, right? And just increase it, set initialized n as 2, set n to 2, and then increase n by 2 each time. But in addition to this, I can simplify my work and use another variable to count for me. So this next variable, usually, this is like a pattern in programming that you wanted to do some specific set of a statement for example, 100 times, for 1,000 times, for, I don't know, as many number of times as you want. Okay, a specific number of times. So we can use a variable that we usually call it a counter. This variable will just increase to just maintain the loop for that specific number of times that we want. So in addition to n, I will create another variable that I'm actually calling it counter. You can call it whatever you want. The name of the variables doesn't really matter for us. But I will use the name that actually makes sense to me. Okay? So I will set another variable and call it counter, set it to 1. And what I will do is that I will write the condition of my loop to just check the counter until counter is less than 10. Okay, do these actions, print n, actually calculate the n for me, the next value of n for me. And not only that, you have to make sure that the counter will be updated as well, because otherwise, again, you will get stuck in an infinite loop. So counter should be set to counter plus 1. So this is going to be the full flowchart, the pseudocode for me. You can say I have one variable that call it n. This is going to be those values that, the variable that keeps the values that I'm interested in. And I have created another variable that just keeps track of the counts, how many times this specific action has been executed, right? You set the counter to 1. You actually check it until counter reaches to 10. So the actions that I wanted to do is printing n, calculating the next value of n, and updating the counter as well. Okay, here you can actually see the flowchart for this one. This pattern is very important. Whenever you are going to actually execute some specific action for a specific number of time, define a variable. Usually we call it counter, or sometimes, for example, some use the name I if you have seen it, I or J or something. We call that type of variables as a counter, because their main purpose is to just maintain the loop for a specific number of time. So the condition that we put for the loop is just a condition based on that counter variable. You initialize it properly, you put the condition properly, and just make sure that you update that counter in the body of the loop as well. Okay, let me actually show you another example, which is more interesting and of course more complicated. Assume that I am interested in calculating the summation of numbers, for example, the numbers from 1 to 100. Okay, how can I write down a program to execute this? How can I write a pseudocode to execute this? Before we actually jump into the pseudocode, we should think that how we do this summation of the numbers as a human, and then we try to actually write down a set of instruction for the computer, which is going to be that pseudocode, right? So to calculate the summation of these numbers as a human, what can I do here? I would say that, okay, first add 1 to 2, right? And say that, okay, 1 plus 2 is going to be 3. It's just like you would say that, okay, I have 3, and then I will add the next number to that, right? But the next number is going to be 3. So you would add 3 to 3, it's going to be 6. So this is the result of adding the first number so far. The next item that needs to be added is going to be 4, right? I will add 4 to the previous result. Okay, this is the previous result. The result is going to be 10, and then I keep adding. I will add the next item, which is going to be 5. So 5 plus 10, this is going to be 15. This is the result so far. And then I will add the next item, which is going to be 6, right? The result is going to be 21, and you will continue. The next item is going to be 7. So this is exactly what I'm doing as a human. I wanted to make it actually, to write a set of instruction that I can give it to any computing agent, so that computing agent can make it, automated. Okay, a couple of things here that I actually see is that I am doing the same action again and again and again and again, right? So look at this one. This action that I'm doing here, adding the next number, adding the next number, adding the next number, adding the next number. So basically you can see that this is in fact the same action. The thing is that those values that I'm adding are just actually increasing. It is first 1, then it will be 2, then it will be 3, then it will be 4, then it will be 5, then it will be 6. Okay, and go on until you reach 200. So it is exactly where you can see that, okay, a loop is going to be useful. I need a loop. I need to write down a loop to actually execute all of these statements in a more structured way. So one thing that comes to mind here for me is that, okay, I need these numbers. These numbers started at 1 and actually go up until 100, right? This is exactly the pattern that I have seen before. So far I can say that, okay, I will write down this pattern for myself, that I would need to get all of these numbers 1 to 100. N is equal to 1, okay? I will write down a while loop and say that until n reaches to 100, until n is less than or equal to 100. And I will actually just, so let me actually double check here, set n to 1, right? And inside the body of your loop, you have to update n as well, because it is first 1, then you want it to reach to 2, then 3, and go on. Set n to n plus 1. Okay, and this is going to be end of the loop, end of the while. Okay, so this pattern that I have written, it just actually generates these numbers, but I'm not adding them to something, right? The important thing that I have done here is that this addition, that you are adding all of these numbers to what? To the previous value, the result of the summation from the previous step. Okay, so even at the first actually step, I could say that the result, the very first actually value for the result that I can think of is 0. You can actually think about it in this way, that, okay, I have 0, which means that I don't have anything so far. And then I will add the first number. So 0 plus 1, the result was 1. Then here 1, this result plus 2, the result was 3. Then you add this result to 3, and then the result is going to change to 6. So if I actually write down the things for you, these numbers are going to be n, right? N was 1 first, then n is going to be 2, then n is going to be 3, then n is going to be 4, then n is going to be 5, then n is going to be 6, right? So in my code, in my pseudocode, I have actually showed you that how n will be generated and will be, you have initialized it as 1 and you increase it by 1 each time. And so this is exactly how you are generating n. But what about the rest of the things? What about this here that you are adding, right? That adding action, and where this result is going to be stored. Okay, basically the computer cannot actually remember the values on its own. Whenever you wanted the computer to remember something, when you are writing a program, you need a variable there. Okay, so basically to keep the result of these summations, I need to define a variable. That here I'm going to call that variable as the variable sum. Okay, that the initial value of this sum is going to be 0, and after you add n to that, you will store it again in the value of sum. Okay, so here I'm going to add another variable set sum. This variable sum is responsible to keep track of all of these summations that you are doing. So sum is responsible to keep these internal values, that after adding 1 to that, after adding 2 to that, after adding 3 to that, all of these values needs to be stored somewhere, right? So in fact, these 3, 6, 10, 15, 21 will be stored somewhere, and they will be stored in sum. Okay, so what will be stored in sum? You can see that the value that comes here is in fact the previous value of sum plus this new value of n that has been actually just generated. So I can write that down in this way that, okay, sum will be, sorry, I keep actually using them. Sum will be set sum to be sum, which is going to be the previous value of sum, plus n. Okay, so at first, let me actually just draw you that table. At first, sum was going to be 0, right? And n was going to be 1. I'm going to set sum to 0. So n is 1, sum is 0. Then you go to this while loop. This while loop is checking that while n is less than 100, n at first is going to be n at first is going to be 1, right? So this condition is going to be true here. Sum, and then you will actually go to the body of your loop. In the body of your loop, at first what you are doing is that you update sum to be sum plus 1. So what will be the new value for sum? It's going to be whatever is the previous value of sum plus n, because you can see that I have actually written that statement here. This is exactly something that the computer will execute, right? So sum will be 1 here. This action that you can see here, this is exactly the first step in that calculation that I have written on the paper, right? And then the value of n here is going to be increased. The value of n here is increased by 1. So the value of n is going to be 2 for the next step. Okay? You are at the end of the loop, so it's just like the computer will go up and check the condition again. N is still less than 100, right? So again, we will go inside the loop. Sum will be updated as whatever is the previous value of sum plus 2 plus the value of n. So it's going to be 3. This is exactly this step. Okay, it was the first step. It was the second step, so sum will be 3. The value of n will be updated as 3 as well. Okay, you will go to the beginning of the loop. Again, check the value of n, compare it with 100. The value of n is 3. It is still less than 100, right? So you go inside the loop. Inside the loop, the first statement is saying that update sum to be sum plus 1. Whatever is sum here and the sum here, n here is going to be the new value of sum, which is going to be 6, right? This is exactly this action here, this action. And then the value of n will be updated here, okay? The value of n, the new value of n will be 4, and the computer will go back to the beginning of the loop, check the loop. Still n is less than 100, so it will actually just keep going and adding all of these numbers. So we are done. This is going to be the full pseudocode, except that at the end I wanted to print that value, right? So at the end of the loop, I need after, you can see that I have written it after, exactly after the end. So whenever I'm done with the loop, when the computer is done with the loop, it will actually come here and print the value of sum. Here is the statement that has been written. I mean, the full pseudocode that has been written properly for you. Okay, I have a couple of fun questions here for you. Okay, let's actually go through them. Assume that you have this pseudocode. So what will be the output of the pseudocode, you think? You can see that here I have a loop in my pseudocode. There is an initialization at the beginning. N has been set to 0. And then in your while condition, you are checking that if n is less than or equal to 2, you will execute this body, right? All of these block of statements. So let me actually just see that whenever you get a pseudocode and you are asked that what is the output or what is the value of some specific variable at the end of the pseudocode or whatever, the best thing is that trace your code. Try to just simulate that how the computer will execute the code. So here you have one variable n, and I can actually just write down, for example, in the output what will be printed as well, but let's actually just write it down somewhere else. So the value of n at the beginning was 0, right? Okay, then here you print, you check the while loop. Because the value of n is 0, this is going to be less than or equal to 2, right? So this is true. So you come to the loop and you print high. So 1 high will be printed in the output. Then the value of n will be updated, right? The value of n is set to n plus 1. So whatever is n will be updated to n plus 1, which is going to be 1. So with the value of 1, you go back to the beginning of the loop, right? Again, you check the condition. Is the condition yet still true? Yes, 1 is less than or equal to 2. So the condition is true. You will go inside the body of the loop. Another high will be printed. So far 2 high has been printed. The value of n will be updated here. N will be updated to n plus 1. So it's going to be 2, right? So you go back to the beginning of the loop. Again, you check the condition. N is 2. Is it less than or equal to 2? Yes, this is still true because n is 2. It is equal to 2, so the condition is true. So another high will be printed here. Okay, so far 3 high. And then the value of n will be updated to n plus 1. So n will be 3, okay? You go to the beginning of the loop. You compare 3 with 2. N is not less than or equal to 2 anymore. So this is exactly where this condition became false, right? And your loop will stop. It will actually just jump out of the loop and see that if there is anything here, it will be executed. But because there is nothing, so your program will stop. What is in the output? 3 high has been printed, so the correct answer is going to be C. How about this one? What will be the value of sum immediately after executing the code? Okay, so it means that at the end, when you execute the code, what will be the value of sum? Okay, here again, the best thing that I can do is that just again trying to simulate how the computer will execute your pseudocode or your program, and just draw a table and create one column for each of the variables. Here I have 2 variables, so one column for n, another column for sum. Okay, the value of n has been initialized here to 1. The value of sum has been initialized to 0. Okay, so I will, by drawing these lines, you just, I'm going to give some, write it in a nice way so it's more readable. Actually, that's what would happen. So then you have a loop. You are checking, comparing the value of n to 5. Is n less than 5? Yes, this is less than or equal to 5. N is 1, so this is going to be less than or equal to 1. So this is true at the beginning. So you are going inside the body of the loop. This statement will be actually written. The statement has been written as the value of sum is going to be the previous value of sum plus n multiplied by n. What is n? N is 1. What is the previous value of sum? It is 0. So what will be actually the result of sum? The result of sum is going to be 0 plus 1 multiplied by 1. Here I could write down the correct answer, which is going to be 1. Okay? But I have written the answers for you in this way just because to make it more clear that I don't want you to get stuck with adding all of these numbers. But at the end, of course, sum is going to be one number. I'm just actually writing it as a summation of a couple of things to make it more readable for you, and you don't just got stuck in all of these summations. Okay, so far sum is going to be 1, and the value of n is going to be updated. 1, or this is going to be 0 plus 1 multiplied by 1. So I'm just writing it here in this way to just make it clear that what happened here. N will be updated as well. How n has been updated? N has been set to previous value of n plus 2. The previous value of n was n plus 2. This is going to be 3. Okay? So then you will go to the top of the loop again. So I'm drawing another line here. Whenever I actually execute one iteration of the loop, I will draw one line to, just make it nicely written and show you that what would happen in each iteration. So now the value of n will be compared to 5 again. It is less than or equal to 5. N is 3. This is less than or equal to 5. So this is still true. Okay? Because it is still true, we will go inside the loop and execute the first line, which is going to be sum is going to be set to previous value of sum. The previous value of sum here is going to be 1 multiplied by 1, right? And the previous value of whatever is the value of n here is the value of n is going to be 3, right? So n multiplied by n is going to be 3 multiplied by 3. So in fact, you need to add these two numbers together, which is going to be 1 plus 9, it is going to be 10. Sum will be in fact 10, but I'm writing it in this way to just make it clear for myself because I'm looking for the answers here. But in fact, what will be stored in sum is going to be 10. Okay? Then the value of this line will be executed. The value of n will be updated. N will be the previous value of n, which is 3 plus 2. This is going to be 5. Okay? I put another line. I draw another line here. You are at the end of the loop and go back to the beginning to check the condition again. The value of n is 5. Is it less than or equal to 5? Yes, it is still true. Be careful. If I was writing it as n less than 5, it would be false. But no, this is true because it is less. 5 is less than or equal to 5. It is still true. You go inside the loop. You execute this line as well again. So here the previous value of sum will be that 10 thing, or the previous value of sum is actually 10. N multiplied by n, the new n is 5, right? So this is going to be 5 multiplied by 5. So the new result here is going to be in fact 35, or it is going to be the 1 multiplied by 1 plus 3 multiplied by 3 plus 5 multiplied by 5. Okay? And then this statement will be executed. N will be updated to n plus 2. So what is the previous value of n? This is 7 plus 2. This is going to be, it was 5 plus 2. This is going to be 7. I will draw another line. So you will go to the beginning of the loop, check the condition again. You can see that n now is 7. This is not less than or equal to 5, so the condition became false. Now the condition became false, so it's just like the loop will jump out and go, and the whole program will actually stop. So what is the value of sum at the end? This is going to be the value of sum, which is going to be part C. Okay? So another question using a flowchart, what will be the value of n at the stop point here? Actually, when you reach to here, what will be the value of n? Again, here you can just draw that table and execute all the steps. So you have two variables here. You have s again and n. S has been set to 0, n has been set to 1. Then you have a condition here. Is n less than or equal to 5? Yes, it is. So this is true. You go here. You update the value of s to be s plus n. So this is going to be 1. The value of n will be updated to previous value of n plus 2. This is going to be 3, right? You go to the beginning of the loop, check the condition again. Is n less than or equal to 5? Yes, it is. So we will go inside. S will be s plus n. So this is going to be 4, right? N will be also updated to n plus 2. This is going to be 5, right? And then you will actually go to the top, check the condition again. N is less than or equal to 5. Yes, this is true. So we go inside the loop again. S will be updated to s plus n, s plus n. So this is going to be 9. N will be updated to n plus 2, which is going to be 7. So you go to the beginning of the loop again. This time 7 is not less than or equal to 5, so it's going to be false, right? You go out. What is the value of n? Check the value of n from your table. The last value of n was 7, so the correct answer is going to be C. Here I have actually added more examples for you. You can just double check this example as well. This is an example. One fun question again about that example. Just try to answer this one as well. If you have any question, you can come to the officers if you didn't know what is the answer here, or I can try to post the answer at the later to the Blackboard as well.